Hello my dear friends, in this video we are going to talk about the trigonometric substitution for integral. So how to do the trig sub for integral? We are going to review some formulas that will be useful when doing the trig sub, and there will be some tips and examples for you guys. So keep watching and figure out how to do the trig sub. Here are some cases that you need for the trig sub. First, when you see there is square root of a squared minus x squared in the integral, or some other patterns in terms of a squared minus x squared, you need to do the trig sub. In this case, you should set x equal to a times sine theta, so square root of a squared minus x squared equals a times cosine theta. Then you will take the terms out of the square root. And second, when you see there is square root of a squared plus x squared in the integral, or some other patterns in terms of a squared plus x squared, you need to do the trig sub by setting x equal to a times tangent theta. So square root of a squared plus x squared equals a times secant theta. Then you will take the terms out of the square root too. For the third one, when you see there is square root of x squared minus a squared in the integral, or some other patterns in terms of x squared minus a squared, you need to do the trig sub by setting x equal to a times secant theta. So square root of x squared minus a squared equals a times tangent theta. Then you will take the terms out of the square root. And remember that when you finish the trig sub, the integral turns to be a trigonometric integral from x world to the theta world. So don't forget to bring the integral back to the x world when you solved the trigonometric integral. Okay, now let's do some integrals for fun. The first problem we are gonna have fun with is this one. Let's go ahead and find the antiderivative of 1 over 1 plus square root of 1 minus x squared. So what do you think we need to do here? Notice that there is square root of 1 minus x squared, the same pattern as a squared minus x squared where a equals 1. So according to the formulas we discussed just now, we should set x equal to a times sine theta where a equals 1, and dx equals d sine theta which equals cosine theta d theta. So here we can write the integral as integral of 1 over 1 plus cosine theta times cosine theta d theta. And now the problem is how to solve this trigonometric integral. There are several different ways to solve it, but here I'd like to times 1 minus cosine theta both on the top and the bottom. You will see how it works later. So we are going to have integral of cosine theta minus cosine squared theta over sine squared theta. Let's expand it and we will have integral of the denominator is sine squared theta itself, and the numerator is cosine theta d theta, which is d sine theta. The second term is integral of the denominator is sine squared theta itself too, and the numerator is cosine squared theta, which equals 1 minus sine squared theta d theta. So here we will have the answer. The antiderivative of 1 over sine squared theta equals negative 1 over sine theta, and the antiderivative of negative 1 over sine squared theta d sine theta is cotangent theta as a basic formula. And the last term is the antiderivative of 1 d theta, which equals theta. And don't forget to plus some constant c. Right, now we have solved the trigonometric integral. So let's bring it back to the x world. Just now we set x equal to sine theta, so theta equals arc sine x. And draw the right angle triangle. We will see if sine theta equals x, then cotangent theta will be square root of 1 minus x squared over x. So the final answer of the integral is negative 1 over x plus square root of 1 minus x squared over x plus arc sine theta plus c. Do you have fun with solving this integral? If you haven't had enough, there will be another fun for you guys. Feel free to try this problem. Integral of x cubed over 1 plus x squared to the 3 over 2. So what should we do here? Of course, we will do the trig sub. Notice that there is 1 plus x squared in the expression. The same pattern as a squared plus x squared, where a equals 1. So according to the formulas we discussed just now, we should set x equal to tangent theta, and dx equals d tangent theta, which equals secant squared theta d theta. So replace x with tangent theta. We will have integral of tangent cubed theta over secant cubed theta times secant squared theta d theta. We know tangent theta equals sine theta over cosine theta, and secant squared theta can be cancelled. So we will have integral of sine cubed theta over cosine cubed theta times cosine theta d theta. And cosine theta can be cancelled. So it turns to be integral of sine cubed theta over cosine squared theta. Now the numerator is sine cubed, so I'd like to write it as sine squared theta times sine theta d theta. Why do that? Look at this part. We know that sine theta d theta equals negative d cosine theta. And the left sine squared theta equals 1 minus cosine squared theta. So it can be written as negative integral of 1 minus cosine squared theta over cosine squared theta d cosine theta. So here we will get the answer. The antiderivative of negative 1 over cosine squared theta d cosine theta is 1 over cosine theta, and the antiderivative of 1 d cosine theta is cosine theta, and plus some constant c. Right, now we have solved the trigonometric integral. So let's bring it back to the x world. Just now we set x equal to tangent theta, so theta equals arc tangent x. And draw the right angle triangle. We will see if tangent theta equals x, then cosine theta will be 1 over square root of 1 plus x squared. So the final answer of the integral is square root of 1 plus x squared plus 1 over square root of 1 plus x squared plus c. So here are the examples of the trig sub for integrals. If you like this video, share, like, and comment. See you next time. Peace out.